Hi everyone, welcome to our Hangout today. I'm Fiona from ScienceAlert, and we are joined by some very talented mechanical engineering students from the University of Waikato in New Zealand, and they're going to be teaching us how to build our own race car. Well, some of the basics. So today we're joined by Todd Carswell. Hi Todd.
Hello.
And Josh McIntyre. Hey Josh. They're both from the WESMO team, which is made up of mechanical and electrical engineering students from Waikato. And so they've built a race car which is capable of going 0 to 100 kilometers an hour in under 4 seconds, and it can also reach 160 kilometers an hour, which is pretty impressive. Makes me feel bad about my mechanical engineer achievements. But they've been racing in the Formula SAE competition, which is Australasia, and they placed 6th last year, and they're about to get ready to race again this year in December, which is pretty exciting. We want you guys to ask your questions while we're chatting, so we're on the hashtag UOW Hangout, and you can also ask your questions in the YouTube comments below. So tell me, Todd and Josh, you're a student team, which is pretty impressive, and you built a race car of your own. What does that involve? How do you build a race car?
Well, it's a very big process. First, there's really just a really big learning curve. A race car is, as we expect, there's a lot of components involved and a lot of theories, a lot of engineering principles. So first, the young members of the team, we try to get them up to speed on all the theory behind a race car, the reasons they run well, the reasons they run fast, and then sort of how to manufacture them. Then once you sort of get over the learning curve, is learning all the rules for our specified competition. And then I guess once you got all that done, you're ready to start designing your own car. For our competition, there's about 150 pages of rules.
Wow.
So, yeah, and they involve safety, they involve restrictions on engine size, and just everything specified. You really need to get your head around that, and you need to understand what sort of car you're designing them for.
Yeah.
And also the style of racing. Our racing is quite tight and technical, more like go-kart racing than actually full-out speed racing. And then sort of you base your design of your car on the application, really. And then, yeah, you look and see what else is around you, what's working well, like which cars are doing well, and what sort of design ideas have they done.
What we can make as well.
Yeah.
And then we do it in time.
Yeah, I imagine that would be tough when you're studying.
Yeah,
definitely. Yeah, so and then you design it to these things, and then from the design stage, it's a lot of back and forth. Like Josh was saying, if you can do it, if you can't do it, it's also some materials. If you can't, then once you have all the design finalized, you move on to the manufacturing, and so that's getting everything made up for the car assembly, and then you go testing stage, and then of course onto the race eventually.
Wow. So would you we're talking about the design, would you sort of go backwards from the applications a little bit, so work out, what the rules are, what the car's needed to do, and then work out from there, use your engineering skills to kind of work out the best design for it?
Yeah, pretty much. Some of what we have done is look at last year's cars and base a lot of our designs off of that, but obviously trying to keep to the new 2014 rules. So we've had a lot of big design changes based on the last year's cars.
Yeah, huge design changes. We took last year's car, which was a very, very good car, and then did a lot of testing with it, and then we saw through the recommendations from last year what was sort of the downsides of the car, or the things we could improve, and then we've targeted all those areas for the design this year. So each year is sort of you try to improve your last year's car.
Yes. Tell me a little bit about the sort of the race. What's the race? I mean, you can see the footage in the background. What's the racetrack like? How long is it? And what are kind of some of the obstacles?
Yeah, I guess the main racetrack is a lot of cones, basically like an autocross track, which is high, it's technical, and you really need to have good acceleration and braking. That's a really big workout on the driver. There's a lot of turns, and a lot of high-speed cruising. But at competition, what we have is an endurance event, a figure of 8, and acceleration,
and autocross, which is one lift as fast as you can around the track. And sort of your scores based around all these events.
Yeah, and how is it only student teams entering?
Yeah. So it's a student competition. There's actually 8 of them around the world, and we compete in the Australian one. And so from New Zealand, if you're listening in from New Zealand, there's Auckland, Canterbury, and us. And there's about 20 or so Australian universities that enter.
That's so cool. I love it. And so tell me, when you talk about manufacturing the parts, we'll get to some of the specifications and budget limits soon. We've got a few questions on how much it costs. But how do you kind of find the parts? Were you taking spare parts of other cars, or were they custom built for your own race car?
Most of the stuff on the cars are all custom built. And I guess to keep the budget, we kind of have to use some parts from last year because it's just so expensive on us. But all the parts we try and design in-house, and we try and get them made in-house as well, but at times it's just too hard to do it, so we have to find an external supplier.
Yeah, absolutely. And we've got a question from Marcus, who had a similar question. He was wondering if you use all new parts or some second-hand parts, but also how much did it cost to make the car overall, would you estimate?
Yeah, good question, Marcus. I guess a lot of the parts are kind of new, but some parts, such as the differential, are from a Mazda, so they are second-hand parts.
Radiator as well. Master cylinders and so we try use as best quality parts as possible, but then of course the cost sort of gets out of hand. But overall, if we were to put a number on it, it's really difficult to put a number on it, and like we say, it's a progression from last year, so we've reused heaps of parts. But we're looking at for about $40,000 to build a car like this. Yeah.
Which is pretty good, right? I mean, how much would a normal race car cost?
Hundreds of thousands.
Depends what type of race car it is.
Yeah.
I feel like I can imagine it would be pretty expensive. So you've done okay. Are there any budget constraints for the competition that other universities have to adhere to?
No, there's no overall rule on it. It's pretty much as you can source from the university or sponsor. So other universities often get the bigger budgets. It's sort of what you get when you make the best of your situation. And of course, sponsorship. We're putting a big push out for sponsorship there. And so anything you get from industries or local companies really helps out the team.
Yeah, absolutely. I can imagine. We've got a question from Brandon, who wants to modify a 1992 MR2 Turbo. I don't know what that is. Hopefully you guys know what that is. So what would you suggest as the first things to modify, and what beasts do you guys drive?
Well, it depends what
I've never said in that context before. I love it.
To make it faster engine, you'd want to make it breathe better. You'd be looking at a better intake system and a new exhaust. If you want to spend a bit of money, make bigger turbos, bigger injectors, things like that.
Maybe an aftermarket ECU or
so they
better
can control on the car.
Nice. So you think it's worth fixing up?
Yeah, definitely. Any project.
And tell us a bit about, you guys, you modify your own cars at home. Like, how did you get started?
For me, I had friends that were into it when we were a bit younger. And sort of you start really, I'm not sure, it sort of turned into a bit of a hobby and then a bit of a passion from there.
Yeah, same with me. I worked on my friends' Cadillacs and motorbikes and just fixed up motorbikes and all sorts of things like that. And obviously my own car, so yeah.
Yeah, oh nice. It's a good passion. And do you both study mechanical engineering, is that right?
Yeah.
Because there are students who study electrical engineering on the team as well, I think. But what made you guys want to get into study mechanical engineering?
I guess for me, I was just like a real hands-on type of person. I love pulling apart things like cars and motorbikes and engines, and at times I knew how to pull them apart, but I never knew how to put them back together, which is probably common.
Which is tough.
I also had a pretty strong physics and chemistry and kind of a maths background, but more like a hands-on, kind of background.
Yeah. For me, it was the same thing. Was quite strong in physics and maths in high school. So it was sort of the right career path. I just wanted to do engineering, and then sort of once you get here, you get the first year to decide what you want to do. You do the broad engineering majors, and mechanical same. It's a really broad subject. It covers a lot of areas, and it just really interested me.
Yeah, absolutely. Well, it sounds like it's been pretty fun. And how many students are on the racing team with you guys?
All up, there's 6 all-fields this year, and our wider team is about 15 to 16 students, and they're from mostly mechanical engineering as well. So there's third and second years, but we also have a student that's studying management.
Yeah, so it's lots of the top teams have a broad range of students. You get marketing students that often help with the sponsorship and the branding of the team, but then you can also get graphic designers and stuff like that, and so that's something we really try to push.
That's really cool.
Yeah, as engineers, our management size skills are exactly up to scratch sometimes. So it's really good to involve these other students, and I think it's good for them as well. We learn a lot doing this sort of thing. It gives you real world application to your degree, and yeah,
it's pretty cool. So tell me about some of the rules and restrictions in terms of the car and the actual engineering of the car that are part of the Formula SAE. What do you have to adhere to? What size can the wheels be? What size can the engine be? That kind of thing.
So like what Todd said before, I think there's about 150 pages in the rule.
Yeah. You need to recite them all now.
Pretty much. But I guess the main constraints that we have as a team are engine size and the chassis.
Engine has to be under 600 cc's, and it has to be 4-stroke and internal combustion. There's all restrictions on chassis size which we can't think of off the top of our heads. And it also has to be an open-wheeled car. So there needs to be a tennis ball needs to be able to go around each wheel without hitting any of the bodywork.
Wow.
And you also have to run a 20mm air restrictor. So this restricts the air coming into the engine and the overall power you can make, just to keep it more safe, I guess. These cars are already pretty quick and they'll be a lot faster without it.
Yeah, that sounds pretty cool. We have a question from Lewis. Does the race car utilize wave turning? And how do you model the exhaust for the best torque band?
Good question. Difficult question. It's what we've tried to do this year, and we haven't been able to get the software working, but there's a program called Virtual 4-Stroke, and this is a simulation software which you input the parameters of your engine, and you can simulate how your engine will work and really the torque. A lot in exhaust tuning is header length. So that's the headers that run off the exhaust of the car. And where the collector is located, which is where the headers come together, moving that location really changes the torque of your overall engine. But from what we've found, because of the 20mm air restrictor, it's often hard to determine this without the simulation, because the air restrictor restricts lots of the flow in the engine and just changes how it sort of acts in the factory state.
Yeah, absolutely. We've had a question from Rusty, and you probably get this a lot. So he said, how does building a race car relate to mechanical engineering? Isn't that more of a mechanic's job? So tell us a bit about some of the engineering applications that go into this.
Yeah, so believe it or not, it is not really a mechanic's job. We do a lot of hand pulling apart the bolts and nuts. A lot of at the start, we're actually designing most of the componentry that goes on the car. And so what we use is a CAD program called SolidWorks, And what we do is 3D model all of the parts in the car, and we actually make like a 3D model of the car all together. And so from this, yeah, we just kind of, I guess, design it.
Yeah, definitely. I'd say, I guess, like I was saying earlier, mechanical engineering is so broad, and this comes under it. You can end up anywhere in industry. And building a car actually involves lots of skills you use in industry. Like you have to do all the right drawings, tolerances, everything like that, and you have to get a lot of manufacturing. A mechanic's job is more the fixing up of things that have gone wrong, where the engineering side is more designing it in the first place.
Yeah, I think that's pretty cool. And I mean, when you talk about sort of 3D modeling all the different parts, which is really cool, do you then go on to print them? Is that how they're kind of created? Is that?
It's more of like a digital format. So we do print them as such, but it's more like a PDF.
Mm-hmm.
And then these are sent off to our suppliers or machinists or.
They make them. So we're not sort of 3D printing them. We're kind of getting them.
Oh, right.
Sorry, that was a bit of a bad question. Yes, 3D printing.
That's cool. The CAD allows us to, or the computer-aided design, really allows us to build the whole car on a computer and work on it as a group. So you can draw up and design a part, and then you can fit to the car on the computer. So you can see that everything fits and it's going to work together nicely. There's also a thing called FEA, which is finite element analysis, and that allows you to add loads and stresses onto an item you've designed. And so you can see if the part's going to break or if it's going to survive in service. So those are really helpful tools when you're designing. And then what we sort of do from there is we take these drawings to a manufacturer with, from this year, you might be able to see these parts. This is our hub. So the wheel bolts onto here.
Oh, nice, yeah.
And these parts are actually machined out of a solid block of aluminium called a billet block.
Mm-hmm.
And so pretty much that's how they're made. They're sent to a CNC mill or a CNC lathe, and they are cut out of a solid block.
That's really cool. And could someone at home, like if someone at home wanted to develop their own race car, would they have access to the, I mean, what are these programs? Can you download them? Would they have access to be able to design things like this?
Yeah. I guess there's a lot of like free edition kind of software, but SolidWorks itself is more like a commercial kind of.
Yes, SolidWorks is very expensive to be required. I think it's about $20,000 for the full license.
Wow.
Like Photoshop or something, I should.
Yeah, but going to university, a lot of universities have a CAD program kind of like sponsored, I guess, as a student edition. And it's just if you do study mechanical engineering, you do learn that program.
Yeah, absolutely. And is it something that professional race car builders would use as well? Is that something you'd use in the industry?
Definitely. They'd have a lot of their own. They'd probably use their own software and not release it to anyone. All the top ones, like Formula 1 and stuff. But, they definitely use this sort of software to design and simulate their cars.
Nice. Chris actually has a question about the program. So he says, is it more comprehensive than Engine Analyzer Pro? And can you use anti-reversion chambers in the exhaust to help increase the draw past the restriction plate during overlap? Sorry, Chris, I probably murdered that question for you.
I should be talking about the virtual four-stroke I talked about earlier. Yeah, we haven't actually got it up and running yet. We've had a few problems with our computer and everything like that, so I can't really answer that question at the moment. But from what we read out, virtual four-stroke is really good software, but it's also very expensive. The only reason we got it was as an SAE team, they sponsor it to you. So we can't really comment on that at the moment, sorry.
No, that's fair enough. And what about the anti-reversion chambers?
Same scenario.
I know that is your favorite topic to talk about.
Yeah, definitely.
But yeah, same thing. So you guys haven't used those. You haven't used those in your car, have you?
Anti-reversion chambers? No, we haven't. We're looking at changing the collector location on the exhaust too. The collector sort of causes reversion, and where you move it changes where you talk. But this year, because we've done a bit of head work on the engine and changed the intake as well, and that's still under construction, it's quite hard to gauge what impact this is going to have on the exhaust. So it's sort of, we need to get these things finalised before we do exhaust, and we've just got to run out of time. So that's definitely for the next year's team.
They can stay tuned.
Yeah, exactly.
Yeah, stay tuned for next year and see how you go. That'll be awesome. Speaking of that, do you guys report back on the things you've learned to sort of help other student teams, or do you keep it quite secret within the formula?
There's definitely a bit of secrecy in the SAE, especially from the top teams. But on the whole, teams are usually pretty. It is a competition at the end of the day, and teams do try really hard and compete. But the whole thing is overall a learning experience. And teams are usually pretty nice. Last year at competition, they broke tripod housing, which means they lost their full drive to their wheels and the car didn't move. And one of the other teams that led them apart to allow the car to race. So, there's definitely the element of competition, but there's also a lot of friendliness and yeah,
just knowledge sharing.
Which is awesome. And you've got the upcoming race, so are you hoping to sort of achieve a certain place? How are you feeling you'll go compared to last year?
It's kind of hard to know, but we see the goal at the start of the year, again, place in the top 10. So, yeah, hopefully we can place pretty well this week.
Yeah, last year's guys set the bar very high again for us. Yeah, no, we're definitely hoping to achieve a top 10 finish this year. There's a lot of competitive things out there, so we'll be really happy with that.
That's awesome. That's really exciting. And we've had a question from Scott about, maybe you guys need a world-class driver. Who does drive? Who drives the car during the race? And how do you pick that? Because that's obviously a lot of pressure for the driver.
Yeah. So at competition, we have 5 site drivers, and all of those drivers are actually part of our team and from the university. So our drivers are a student and one of our fourth years, and the rest are in second year.
And so none of them are really professional drivers, I'd say. It's hard to find those at university, I guess. But what we really try to do is try to do some driver training and try to get them seats in the car and get them as comfortable as possible before we actually race. Yeah, we've got, luckily, the student we're talking about earlier, he's actually driven quite a bit of Suzuki and done quite a bit of karting. We hope he can really help push other drivers to really understand our car and drive well.
Yeah, that's fantastic. We have a question from Thomas. Did you implement VTEC into your design? Is that like a thing?
We use a Suzuki DSXR engine, so it's actually from a motorbike, so we definitely don't use
Yeah, no. Motorbikes don't tend to have that, and implementing something like that would be a lot of work. You'd have to rearrange that.
Tell me about some of the parts of your car this year. I mean, not without giving away too much, obviously, because you're about to compete. But how much does it weigh, and what are some of the specifications you can tell us?
It's not fully finished. We don't know the exact overall weight, but we're looking to cut about 15-20 kgs out of last year's car. So this should end up with a total weight, fully ready, track ready, of about 235 kilos. And other specifications, I guess we're aiming for about 80 horsepower again. We have modified the engine a bit, so we're hoping for more linear power and rather than quite peak like and we've got 4 new suspension geometries this year, which should help with the curves and handling of the car. And
absolutely.
Reduce the unsprung weight of the car, so that's the weight that's sprung on suspension. We've reduced that by about 10%, which should also help improve the handling.
Nice. Yeah, we actually had a question from Lachlan about chassis geometry and how it affects handling. Is that something that's got a big impact for you guys?
Yeah, I guess chassis is probably number one for your torsional stiffness. And so what a lot of teams do is either a chassis, a steel chassis, which is steel and tube, and those are all tubes that are welded together. Or you can go down a monocoque kind of style, which is a carbon fibre, and it's all like a moulded tub.
Like single. Yeah. As for us, to try and improve torsional stiffness, the better it is, the better your car's going to handle, because the least it's going to sort of be turning. So for this, the guys really designed it with triangulation in mind as well. So all the members of the chassis have to meet at one point. And also, like we were saying before, the CAD software has been used extensively with the finite element analysis, and so this allowed us to load up the chassis, see where the weak points were, and then redesign it for that. And this year we've actually reused the chassis from last year, as they did a really good job with it last year, and so yeah.
Yeah, very cool. And in terms of, your favorite part of putting the car together, is it, both of you are probably different, but is it designing it? Is it trying to make it meet budget? What's your favorite part? Is it when you finally get to race it on the track?
Oh, my favorite part is probably the entire project, to be honest. Yeah. We're doing lots and lots of different things each day. One day we might be sitting in Todd works doing our CAD design. The next day we're down in the workshop in the lathe or workshop welding. Or the next day we're out on to fund the project through sponsors and doing events like this. So yeah, it's really varied, and I think both me and Todd enjoy lots of different parts of doing this project.
Yeah, I have to agree with both, really. I think it's the overall thing. There's no part that really sticks to me. It's seeing you've put all this work into the design and everything, all this work in assembly, and I think finally seeing your finished product, it's really, really rewarding because of that.
Yeah.
No,
that sounds awesome. I think it'd be very cool. I know we were talking earlier that you guys spend a lot of hours. At the moment, you're doing like 80 to 100 hours a week on the car. That's pretty full on. Alan Chu has a question. So, a question from Preston. His university has a new Formula SAE team. Do you have any tips for success for someone who's sort of doing it for the first time for rookies?
Yeah, I guess my tip would be simple. Your first time, I guess, try and just get your car running. Try and get it reliable, and yeah, try and design it so components don't break, which is easier said than done, I guess.
I'd say there's lots of literature and tricks out there which are really, really good for starting up teams. We had some Carroll Smith and things like that, a really good read, and yeah, like Josh said, make sure it runs, and then every year build on that. I think the key thing is just if you've got a running car, you're going to keep the team spirit up, and you're going to build on that.
Yeah, absolutely. I think that's the main thing, I guess, keeping it together. And what happens to the car? I know you reuse parts, but at the end of the race, what happens to it? Does it get broken down, or do you keep it for next year?
Yeah, we try and take it down for shipping because we have to ship it back to New Zealand. Hopefully this year, which we've never had a chance to do in the past, is actually keep the car as a rolling car. So hopefully what they can do in the future at least is have two cars drivable. That way we can actually have a lot of driver training.
And also a full car for events, for uni days, events or anything like that. And it's also really good to have a full car that doesn't reverse or anything. So if you keep two cars going, it's just going to make it a whole lot easier on the team. But as you have to source everything again, and you can't reuse any components, which is it's a lot of work.
Yeah, absolutely. I can imagine, because you kind of want to tear it apart in some ways. So tell me a bit about where your workshop is. I mean, where do you work, and what are the tools like? Are these tools that people could have access to in their own home, or do you really need to have sort of a proper stocked workshop to build a car like this?
So our workshop's on the science and engineering block. Pretty much we have normal tools that anyone can buy down at their local car part shop, I guess. We have spanners and wrenches and drill bits and drills, but we don't really have anything too advanced. We do have a drill press, but
and a linisher
and like a grinder and a welder. But to do anything really complicated, you do need some advanced equipment, and we do have workshop facilities available to do that here.
Yeah, basically, in our workshop we have Jose, but I think you can often learn lots of those basic tools, but it might mean that in the more technical parts you're going to have to outsource the industry, as we
Yeah, absolutely. I mean, what are some of the benefits if people wanted to build a car at home? What are some of the benefits of doing that as opposed to kind of, buying a car, or what are some of the benefits of even upgrading your own car rather than just buying one and a new one?
I guess it's to save money at the end of the day.
Yeah.
Just doing things like changing your oil or changing your air filter or changing your brake pad just saves you money.
Yeah, I think when it really feels more personal. And I think you enjoy it more. And like Josh saying, if anything goes wrong, you can replace it, save a lot of money and a lot of hassle.
Yeah, absolutely. And we've got a question from Thomas. And again, this is a question that I don't understand fully, so I'm going to read it out and hope that my mechanical engineering knowledge makes sense. Do you run a titanium flettle, or do you use a flux capacitor to get around the stress associated with that?
I don't think that's a serious question.
Really?
No, I think I know who Thomas is.
Sounds like see who can make you read out the bad questions. But that would be impressive, right?
Very impressive.
If you did, yeah, I think that'd be pretty impressive. I'd be looking forward to seeing that. Tell me a bit about what the most useful tool for you guys is that you use all the time.
Most useful, was it?
Probably the hammer.
Yeah.
I thought you were going to say something really exciting, like a flux capacitor or something.
No, I think most important basic tools is Allen keys, hammers, which I think is really cool. People DIY and do most of it yourself.
Yeah, absolutely. And so talk to me about the race coming up. What event are you guys most looking forward to? Do you have one that you feel like you're going to really do well in?
I think the big one's always the endurance. You have for the whole competition, it's all out of 1,000 points, and so you have points awarded for your static events, like presentation and costing and your design of your car. And you have points for the dynamic event, for the race events we described before. I think the big one is endurance. That's worth the most points out of anything, and that's where all the cars that are not built up to scratch or have weak components will fail. And so that runs for pretty much a full day, and that's the event that everyone's hanging out for, really.
Yeah, absolutely.
Yeah, so it's a 30-lap race, and really tests your car and on its strengths and weaknesses, and yeah.
Nice, and that's, I guess, where you really kind of see if what you've come up with in the lab and on the computer programs and stuff really pays off when you get out there.
Definitely.
Yeah, absolutely. What do you guys want to do when you graduate? I mean, what's the ultimate career? Do you both want to work in the car industry?
Well, I guess we don't really have that much in the car industry in New Zealand.
Well, you can move, you can travel.
Both me and Todd actually have graduate jobs, and we actually have it at the same company. So, but definitely for me, I guess long-term, like career prospects, I guess, is just getting a job that just challenges me. Is really interesting.
Yeah, I don't really have a field either. I guess it's just sort of go as it happens, Yeah. I would love to be in the car industry and do this sort of thing, but as Josh was saying, it's quite hard to get into. But I think lots of engineering is really interesting and challenging, and I think it's a really good field to be in.
Yeah, absolutely. And so what kind of skills have you built up so far that you feel like would be valuable from the competition? I mean, we talk a lot about, what are the real-world applications of this, how can you use it, but what are some of the things you've taken away that you find will be really useful?
I guess probably one of the things that we haven't really talked about is actually our communication skills.
Mm-hmm.
And we're just crazy talking to like sponsors and our
industry and
lots of people.
And even between ourselves, I think communication in any company is huge. And often it's the soft skills like sending emails,
Talking on the phone.
Yeah, exactly. And I think even though we've learned all these technical skills, I think these ones are the ones that really pay off in industry, and I think these are the ones that are really, really important.
Yeah, absolutely. I mean, and it's something that I guess you don't associate with engineers. Sorry, no offense, but generally, because you have all the tech skills and you learn, all the science behind it. But I guess it's not something that you use on a daily basis. So it's probably really exciting to be able to practice those and have them proven.
Yeah, and it's not something you learn in lectures as such. You need to actually do it first person and experience it.
Yeah, definitely. We have a question from Matteo. Can you talk about some of the biggest differences in terms of performance between the car that you guys work on for Formula SAE and a Formula 1 race car?
I guess number one is cost. Formula 1, most of the components, carbon fibre and really flash, millions of dollars. Some of these teams have over $500 million.
Wow.
So the biggest differences really are in the size of the car. Our car's a lot shorter and probably a lot skinnier as well than a Formula 1 car. And we also have a lot smaller tyres.
Just the racetrack's a lot different. The style of racing, Formula 1's like big open tracks with high speed, where this sort of racing is more smaller in between cones all across tracks. So these cars are really, really designed for handling, acceleration, and braking as the main sort of areas instead of overall top speed.
Yeah, absolutely. And in terms of, I mean, we talk a lot about kind of trying to get electrical cars up to the performance of race cars and even regular cars on the road. What could you sort of integrate some of the things that you've developed in the system that you've got at the moment with a more sustainable system, sort of like a solar car or an electrical car?
Yeah, in the competition there's actually a new electrical division.
Oh, cool.
And so there's about 4 cars last year, I think, that raced at that. They run alongside us in the separate categories. And so, there's definitely been a big push. It's often the electric cars are really, really quick. They're quite heavy with all the battery packs and everything like that. But just the electric motor has lots of torque and huge amounts of power off the line. So an acceleration to these events, they're really, really fast. And because you can arrange the batteries when you need them, you can keep the mass and the weight all centered low and where you want it. So these cars are, I think they're really, really being phased in as a competitive. And what we've done in our car is mostly towards the internal combustion, petrol engine. But definitely there's a huge area for electric cars and its sustainable solution.
Absolutely, and I guess if they are engineered correctly, I mean to get the balance right and the steering right, do you think they can be as powerful as the race cars that you guys are driving?
Yeah, that don't sound good. But no, definitely. Yes, and there's huge potential. All the technology in them is still improved every day. Definitely huge potential for very fast cars.
Probably the number one setback with electric cars at the moment is the batteries. And just the ability to charge them,
and they're very heavy.
Yeah, and I guess in the future it's probably an area. I mean, do you guys learn about that in your lectures and things, sort of how to move? It's probably going to be a growth industry, I guess.
Yeah, definitely. And huge amounts of research and everything into batteries at the moment, and they're just being improved all the time, and including solar panels. They're just getting better and better as well.
Yeah, absolutely. I mean, we hear about student teams actually are driving a lot of the innovation. I mean, I know over in Australia we've got some student teams that are building really amazing solar cars. So it's nice to see students getting out there and actually driving the industry, because I guess you're not so focused on making money and
Yeah.
can actually experiment with new things.
Yeah, Waikato Uni actually well push with electric vehicles too.
Yeah.
Like solar race cars and electrical cars that have travelled of New Zealand.
Yeah, I remember they had the one that went over Mount Cook and everything. It was crazy.
Yeah, that's
Yeah. Well, it's pretty impressive. I mean, it's just amazing to see that, you know, these technologies are coming through. Would you personally want to work on those types of electrical solar cars, or are you happy with fuel?
it's a hard question. I love the petrol cars, but yeah, I could definitely see myself doing some work with electric cars and in that sort of industry.
Yeah, absolutely. And what are some of the skills that you would recommend to people who are thinking about, you know, maybe they love cars, maybe they like science, and they want to get into a similar industry? What are some of the skills that you think they might need, and some of the tips you might give them?
Yeah, I guess there's a lot of skills that you do need to get into engineering, but I guess number one is probably getting your maths and physics and getting those academic skills nailed down and just try and do well in the subjects. The other one is just trying to be a problem solver.
Yeah.
Engineering is really all about problem solving. And so just try and practice those problem solving sort of skills just on anything, you know. And yeah, just try and refine your skills.
Yeah, I think like really willingness to learn. Engineers, the industry is always changing. You're always learning. Yeah, you're always solving problems, and so yeah, I think just really that sort of passion and just enjoy it.
Yeah, absolutely. I think that's such a good tip. And for you guys, what's been the best thing? I mean, obviously the changing facet is pretty cool, but what's the best thing about studying engineering at University of Waikato? What are some of the opportunities you've had?
Probably summer job availability. We have to do a summer placement for our degree, but what I've found anyway is that at Waikato we just really wanted industry, and yeah, I've just found it really inviting and probably
the engineering department is quite cool at Waikato, which has its drawbacks, but it's not a bad thing. We really get to know our lecturers really well because the classes are quite a bit smaller than other universities. And that's really good. You get to interact, and I think you learn a lot better. We've got a lot of hands-on papers, and of course, building a car really hands-on. And I think these things are really important and really enforced at Waikato.
Yeah, absolutely. So what's left to do? I mean, winding down, kind of counting down before the race. What do you have to do now?
Get all our car assembled and get it tested.
Yeah.
On Monday coming, we have to have a dyno change. That's sort out all the engine and all the fuel and the power. And then from that, we'll go on to a testing session where we'll try and test the car, see how it handles and what things we need to change. Get the drivers some time in the new car, and then just start preparing for a competition.
Yeah.
Yeah. Very cool. And do you guys go over to Melbourne for a little while before and after the race, or is it just over for the weekend?
No, definitely before. We're heading there a week in
3rd of December.
Yeah, 3rd of December.
And so that's week and a half out from competition.
Pretty exciting. Yeah. Nicholas wants to know, I feel like this is another question for you guys, especially. Why no wings on your cars? Wouldn't that make it go faster?
It's definitely an area being researched into by a guy called Nicholas, so it might be that one asking the question. But,
yeah, I was imagining.
As a whole, our car, we run with the 4-cylinder engine. You can also run with a single-cylinder small engine. So we have a lot more power available, but that makes it a bit heavier. So overall, we find we get enough grip, mechanical grip, and handling enough power down without the wings at the moment. In the future, there's definitely room to add wings to the car, but we'll probably look at going to a smaller, lighter chassis and then using the wings to gain that downforce and weight at the highest. Overall, designing and building wings is a massive process, and the engineering and science behind it's still relatively unknown. So you can't really take it lightly. huge process, but definitely in the future there's room for that application.
Absolutely. And are there any other up-and-coming technologies that you guys want to look into in the future that aren't quite there yet? That maybe, you know, people out there watching who might want to build a car might want to know about?
3D printing?
3D printing, yeah. I guess one of the emerging technologies is obviously 3D printing, but there's also this one called laser sintering, which is actually printing steel.
Or a titanium alloy. Like that, and they can make really strong parts, but the great thing about them is they can make very intricate parts, which are very hard to make otherwise. And so doing these can take a lot of weight out of a component. But there are also still drawbacks because it's such a new technology, the fatigue and sometimes the strength, sometimes they're quite brittle, the parts. So it's a difficult area because if you put them into the car, you're still quite unsure how they're actually going to act. But definitely in the future, there's room to use this sort of technology.
Yeah, absolutely. I think that, you know, that's obviously pretty exciting that you guys can play around with it. Thank you so much. I think we're out of time, but we had some great questions, and I hope that you guys watching learned something, and Todd and Josh, we didn't drive you crazy with too many weird random questions. It was great, but good luck in the race, and we'll be watching and hopefully learning from some of your successes and finding out about how everything went. Is there anything you guys want to add, or any messages for the rest of the team who might be watching?
Just always start to say, bro, thank you to the sponsors that have really helped us through. And yeah, I hope all the other teams that are gearing up for the competition are going all right.
Look forward to seeing.
You don't mean that though.
No. Yeah, and thanks for the opportunity to be on the Google Hangout. It's been awesome.
No, it's been great. Well, thank you so much. If any of you guys are interested in studying engineering or want to find out more, there are some links in the YouTube description. Just check out University of Waikato. They've got some great courses, and you guys can be on the WESMO team too, which is pretty awesome. So it's been so great to talk to you. Both have a wonderful day, and we'll speak soon.
Awesome. Cheers. See you later.
Bye.
The University of Waikato, where the world is going.